Today we're doing lesson 14.1, which is square roots. Our key idea, a square root of a number is a number that, when multiplied by itself, equals the given number. Every positive number has a positive and a negative square root. A perfect square is a number with integers as its square roots. The symbol, and it kind of looks like a fancy check mark there, is called a radical sign. It's used to represent a square root. The number under the radical sign is called the radicand. So our table here shows you what the positive, negative, and both square roots look like. So positive square root, that's when there's just this symbol. You're going with the assumption they want the positive one. Positive square root of 16 is 4 because 4 times 4 is 16 and 4 is a positive answer. If they want the negative square root, they'll put the negative sign in front of the radical symbol. So the negative square root of 16 is going to be negative 4. And then if they want you to find both square roots, then they'll have that plus minus sign in front of it. So the positive and negative values of the square root of 16, positive 4, 4 times 4 is 16, and negative 4. Negative 4 times negative 4 is negative 16. So I'm showing you a table here of all of the, well, not all of the perfect squares, but the first through the number 10. The perfect squares list, and then what you get for the square roots. So perfect squares mean that it is the area of a square that has whole number side lengths. So 1 squared equals 1, 2 squared equals 4. This middle column is our perfect squares. And when we do a square root of a perfect square, we get that original integer. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on. All right, so for our purposes for this lesson, we are not using calculators. We're using what we know about numbers, and we can use a table similar to this one to help us solve our problems. So for this one here, it says find the 2 square roots of 49. So they're asking for both the positive and the negative value for the square root of 49. 7 and negative 7, because they asked for both square roots. 7 times 7 is 49. Negative 7 times negative 7 is also 49. All right, so let's take a look at some other examples here. So A, find the square roots. They didn't say both square roots. So we're just assuming that this one right here for A, they're asking us to find the positive square root of 25, and that would be 5, because 5 times 5 is 25. Now when we have a fraction like B here, we have the negative square root of 9/16. You can find the square root of the numerator and the denominator separately and then write your fraction. So square root of 9 would be 3. 3 times 3 is 9. Square root of 16 is 4. 4 times 4 is 16. So when we do the square root of 9/16, that's going to be 3/4, and it's negative because they gave us that negative sign. All right, and then for our last one, the square root of 2 and 25/100. So, I know I need both a positive and a negative value there. And I need to do a little bit of guess and check. I know I'm going to have a number with 1 decimal, because when I multiply a number with 1 decimal times another number with 1 decimal, I end up with a number with 2 decimals, because when we do decimal multiplication, we count up the number of decimals in the problem. That's the number of decimals in our answer. This radicand underneath here, that's our answer to our multiplication problem. 2 decimals, that means there's going to be 1 in each number. So you can think about this. If you get rid of the decimal and you think of this as 225, well, 15 times 15 is 225. But they gave us a decimal there, so instead of 15, I have 1.5. Sometimes you have to do a little guess and check. You can think about, okay, well, I need 2 numbers that are going to multiply to equal something that ends with a 5. So 1.4 isn't going to work. 1.3 isn't going to work to end in a 5. The other way to do it, to give you a place to start your guess and check, is if you go to our list. So I have this list here, and it's pretty easy to make one for yourself if you want a physical copy. I know that 2.25 is in here in between square root of 1 and the square root of 4. And I know it's going to be a little bit closer to 1 than that. So it's got to be right in between 1 and 2 somewhere. So I'm guessing 1 point something. Okay, so anyways, for that one, I ended up getting 1.5 and -1.5. With decimals, you got to do a little guess and check, or things that are not perfect squares. You'll have to do a little guess and check sometimes. Okay, so we've got 4 problems to try again for today's lesson. We are not using calculators. Go ahead and find your answers for these next 4 problems. Go ahead and pause the video and try these problems. Okay, let's check to see if you did your math correctly. Okay, 1 and 2 say the 2 square roots of the number, so make sure you have both a positive and negative answer. Number 1, you should have had 6 and -6. Doesn't matter which one you put first. If you put the -6 first, that's totally fine. And then for 2, you should have 11 and -11. For number 3, we only want the negative value of the square root of 1, which is -1. And then for 4, we need both the positive and the negative value. We do the square root of each part of that fraction. So the square root of 4 is 2. The square root of 25 is 5. So I have 2/5, and then I also have a -2/5. All right. And our next type of problem here is an order of operations problems. We've looked at ones like this earlier in the year. It's just these ones happen to have square roots in them. The square root is a grouping structure. So it goes in our order of operations along with parentheses. So anything that's inside of a square root sign acts like a parentheses. You have to do anything inside of it first. Just like a parentheses, when you see a number in front that's touching it, like an A here, I have 5 right in front of that radical symbol. That means 5 times the square root of 36. So it's acting just like a parentheses here. It's just instead of a parentheses, it has meaning. So we are going to go ahead and evaluate whatever is in the square root acts like parentheses, and then we do square roots in the second step, which would be like where we would do exponents if we're thinking about our PEMDAS for order of operations. So let's go ahead and talk through these problems. First one, 5 times the square root of 36 plus 7. Order of operations, parentheses, nothing inside there. It's just the number 36. Exponents, we're going to do the square root of 36. Square root of 36 is 6. I've replaced this radical symbol with parentheses to mean multiplication. I could have just written a multiplication sign if I wanted to. Then I do multiplication before addition. 5 times 6, that's 30. Plus 7 is 37. That's the value of that particular expression. All right, let's take a look at B. 1/4 plus the square root of 18 halves. So again, I said that this acts like parentheses. So 18 and 2, neither of those are perfect squares. So I'm not going to be able to do the square root of 18 over the square root of 2 as easily as what I did on that last slide where I did 4 and 25. They're perfect squares. It doesn't work so well, but I can do 18 divided by 2 because it's within that radical symbol. I can go ahead and do that operation. That's 9, and then that is a perfect square. So I can do that evenly. Square root of 9, that's going to be 3. And then I have 1/4 plus 3 is going to be 3 and 1/4. All right, I've got one more for you down here. So the original problem, let me erase it so you can actually see all of it. There we go. So for the original problem, I had the quantity, square root of 81, squared, minus 5. The squared and the square root are inverse operations. Just like addition and subtraction cancel each other out, square root and squared end up canceling each other out, and it gives you 81. Here's why. I'm going to erase it one more time so you can see it. If I did the inside of that parentheses first, and I did the square root of 81, that gives me 9. And then I have the squared on the outside. 9 squared equals 81. So I did parentheses, and then I did exponents, and then I subtract. So 81 minus 5 gives me an answer of 76. All right, let's take a look at this story problem. The area of a crop circle is 45,216 square feet. What is the radius of the crop circle? Use 3.14 for pi. Okay, so I said we weren't going to be using calculators today, and I did mean for the order of operation type problems, the square root type problems, we're not using calculators to do those. But for one like this where we have such large numbers and we're dealing with pi, we will go ahead and use a calculator to help us out with this one. So if you think back to chapter 8, our area formula for the area of a circle is area equals pi times radius squared. They told us to use 3.14 for pi. So we substituted by putting in our area in for A. We had to get R by itself, and this is multiplication. We cancel out multiplication with division. So I divided both sides by 3 and 1400ths. When I did 45,216 and I divide it by 3 and 1400ths, I get 14,400. Then I have to cancel out the square root, or I'm sorry, I have to cancel out this exponent. To cancel out the exponent, I have to do the square root. As I showed in the last problem, square root and squared cancel each other out. So if I do the square root on both sides, that gives us, instead of r squared, it gives us now r. And the square root of 14,400 is going to be 120 feet. All right, so go ahead and try these next 3. Feel free to use a calculator for number 7 if you would like. Go ahead and pause the video and try these problems. Okay, let's check our answers. So for number 5, we don't have anything in parentheses. There's no operations within the radical signs. So our next step would be exponents and radicals. Square root of 25 is 5. I've replaced that radical sign with parentheses to show multiplication. Multiplication comes next. 3 times 5 is 15. Or if you wanted to do boom, boom, negative 3 times 5 is negative 15. And then 12 minus 15 gives me negative 3. For number 6, my squared and square root cancel out, gives me 4. I could have done square root of 4 is 2, and then 2 squared is 4. Gives me the same answer. And then I have to do 15 minus 4, which is 11. And then for number 7, we set up our equation. The area, 2,826, equals pi times radius squared. We divide both sides by 3.14, which gives us 900. Then we take the square root on both sides to cancel out the squared. So 300 feet is the radius for that circle.